I am Anil Kumar. Welcome to my series on statistics. We'll discuss box and whisker diagram in this particular video. We'll talk about its interpretation. I've taken three examples. With the help of these examples, we'll understand how do we interpret box and whisker plot. Here are some key features which we should keep in mind. Quartiles divide the set of ordered data into four groups. So normally, we'll represent a box and whisker diagram on a number line with the ends, which represents the lowest and the highest data values, and the box represents the quartiles Q1, Q2, and Q3. Now, these three quartiles actually divide the whole data in equal parts. That is to say, that in the first quartile, which is from the lowest value to Q1, we have 25% of the data. In the second quartile also, we have 25% of the data. So there is 25% data in each quartile. Perfect. So that's the second point, which is there are equal number of values in each group. First quartile Q1, median, or the second quartile Q2, and the third quartile Q3 are the points dividing the data. Interquartile range is Q3 minus Q1. So Q3 minus Q1 will be referred to as interquartile range. That gives you the spread in between, right, for most of the data in the center. Semi-quartile, semi-interquartile range. This is another very important term, semi-interquartile range, which is half of this, right? Which is half of this, half of interquartile range is also sometimes considered to see the spread. A modified box and whisker plot is used when data contains outliers. So if there are outliers, in that case, at times, we will use slightly modified diagram. We could make the lowest element like this, for example, if this is an outlier, and then take the next element like this. Do you understand? So in that case, we keep the outliers separate because that is just one element, right? One piece. So that could represent the other, most of the 25%, almost 25% within the lowest value and the Q1. Outliers are at least 1.5 times of IQR away from the box, right? So when I say outliers, that means on the lower side, if it is less than Q1 minus 1.5 times IQR, or if it is greater than Q3 plus 1.5 times IQR. So that is how we'll define the outliers. Keeping all these things in mind, now let us discuss a few examples. Question number 1 here is, box and whisker graph below shows test results of a math class. Now we use the terms box and whisker graph or a plot or a diagram many times. So these are the math marks, the lowest being 23, the quartiles being 64, 85, 93, and the upper limit is 104. Based on this, we have 4 questions here. You can actually pause the video, answer these questions, and then look into my suggestions. A. Write down the mark which is exceeded by the 75% of the students. B. What was the range of the mark obtained? C. What is the range of the marks that the middle 50% students scored? D. Would you expect the mean to be above or below the median? You can pause this and then look into my answers. Now let's talk about the answers in this particular case. We're saying write down the mark which is exceeded by 75% of the student. So clearly the mark is 64. All the students on the right, which corresponds to 75%, since this is 25%, right? This data is 25%. So the 75% is on the right of this, right? This is 75% of the data. Therefore, the mark which is exceeded by 75% of the student is 64. Clear? Now, what is the range of the marks obtained? So whenever we want to find the range, it is always maximum minus minimum, right? So you'll do 104, take away 23 to get the range, right? So that gives you 81 as the range. What is the range of the marks that the middle 50% students score? Now, middle 50% is this. So we really are interested in finding IQR, right, interquartile range, basically, correct? So this is 93 minus 64. So 93 minus 64 gives you 29. So that becomes 29. D is, would you expect the mean to be above or below the median? Now the median here is right there. Now you have to see the whisker, right? So this whisker is longer, so the mean will go below, right? So mean will be below the median. We can say it's because of the outlier on the lower side. Outliers change the mean. So we're looking into this position here, which is an outlier clearly, and therefore it is going to go towards the left side. Now let's take the second case. I hope you have understood how do we interpret a box and whisker plot. So again, we have a box and whisker plot. This time is shows the time taken in minutes for students to complete an assignment. Based on this, we again have four questions. First one, what percent of students took more than 40 minutes to complete the assignment? What is the range of third quartile for the time to do the assignment? What percent of the students did not complete the assignment? Would you expect the mean to be above or below the median? So you can pause this and then look into my suggestions. So the first one here is, what percent of the students took more than 40 minutes? So 40 minutes is right there. So that is the first quartile. More than 40 minutes means 75%, correct? So 75% is on the right side of this. So 25%, 25%, and 25% makes it 75%. What is the range of third quartile for the time to do the assignment? The range for third quartile is this one, right? From Q3 to Q2. So 90 minus 60, that gives you the value, which is 30. That is the range. What percent of the students did not complete the assignment? Now, we can see from here that all the students have completed the assignment. So we will say none, zero. Would you expect the mean to be above or below the median? Now, since we have an outlier on the right side, so whisker is longer on the right, correct? So that means it will be above, right? Or it will increase, so it will write above the median. Is that clear to you? So that is how we can answer such questions. Let's take more examples. This time we are taking two box and whisker diagrams. We'll compare the data. This is also a very common question in many test papers. Question number 3 here is the marks of female students in green and the male students in blue are summarized below. So these are female students and these are male students. A. Which plot represents more consistent performance? B. Mean for the female students will be higher than the median. Is it true? For whom is the first quartile higher? Compare the semi-interquartile range for the students. What does that indicate? So I hope you got the answers. Let's look into them. Which plot represents more consistent performance? So more consistent means more compact, means less range. Correct? So clearly, the plot for the girls is more compact. So for this, the answer will be girls, right? The female, the first one, correct? So you can compare the range to find which one is more consistent. So most of the data is compact within lower limits. So this is more consistent from here to there, correct? Now, second, mean for the female students will be higher than the median. Is it true? So we'll say this is true since we have a whisker which is longer on the right side, right? So it is true. So since the whisker is longer on the right side, for whom is the first quartile higher? So let's look into the quartile. This is only that much and this is much longer. So it is for the males. Compare the semi-interquartile range for the students. What does that indicate? So semi-interquartile is half of interquartile. That is what it is. So let's calculate for green. For females, it is what? Let me write it in green. So it is 50 minus 20 divided by 2, which is 15, correct? For boys on the other side, the males, it is 90 minus 40 divided by 2, which is 25, correct? So compare the semi-quartile range for the students. What does that indicate? So it is higher for boys, lesser for females. So it is compact for females. So that is how you can say. So that is more number of female students are closer to the central value, right? Do you understand? More closer to the central value than for the boys, than for the males, right? So this is more compact, consistent. So that is how you can actually compare because based on the range, right? So I hope that is very clear. Once again, semi-interquartile range is half of the interquartile range and it represents spread of central half of the data, right? So it represents the spread of the central half of the data. So that is important to understand. We'll extend this and have few more questions based on the information given to us. Here is E, which is if there are 80 boys, then how many of them scored more than 90% marks? 50% of the female students failed in the test. What was the passing mark? For whom is the first quartile higher? Means male or female. Write a short paragraph comparing the marks of the female and the male students shown in the figure above. So these are very popular questions on such box and whisker. I'd like you to pause the video, answer these one by one. Let's look into the very first. If there are 80 boys, then how many of them scored more than 90%? So 25%, right? This is 25% of, in this case, 80, correct? So which means one fourth of 80, correct? So that means 20 students. So 20 students scored more than 90% marks. 50% of the female students failed in the test. What was the passing mark? So if 50% fail, 50% means from the median, correct? So that is what we are looking at. So that is 40. So the passing marks is 40%. You get the idea, right? So 40% is the passing mark. For whom is the first quartile higher? So for whom is the first quartile higher? We actually answered this question earlier also. It is for males. And now write a short paragraph comparing the male and the female students shown above in the plots, correct? So now you take your time. We have actually very good information from our examples. So you can pick up this information which we did and compile it to compare. So mainly you will see that the data given to you is more consistent for the females than for males. However, there are many male students who have scored more than most of the female students, you can say. Like the highest mark for the female students is only 80, whereas they have at least 25% male students who scored more than 90% marks, right? So that is how you could compare it. With that, we come to an end of this particular video in which I hope you have understood how do we describe box and whisker diagrams and how do we read the information from them. Thanks for your time. In case you want to learn from me, you can always send an email on the address given here. Also, check our website for the latest videos. Thanks for your time and all the best.